Hello everyone, thank you for joining. So today I'm going to present the software Pier we developed at Oak Ridge Nation Lab. I'm Amine Turki and this software was developed in collaboration with Nolan, Balaji, Selvakumar, Bryan, Maldonado and Nolan. And the software consists in automating the segmentation and analysis of Pier foundation based on point cloud. So a Pier foundation consists of vertical columns to support the structure and elevate it above the ground. It is mainly used in locations with unstable soil, expensive soils, or where basement construction requires additional support. Today in the industry, the methods to place Pier foundation are mainly manual, which can be imprecise, and as a result, errors can easily go unnoticed. The most advanced techniques currently used in the industry involves laser scanning techniques, which are time-consuming and require skilled labor. So tools usually used in manual methods are shock lines, measurement tapes, and bubble levels. So as I said, it can lead to a lot of imprecision. So with placement error where the piece is not where it is supposed to be, so the piece does not support the load, or elevation error when we leave a gap between the structure and the piers. So this kind of error can severely impact the building and leads to a total rework. And regarding advanced method with involving laser bubble levels and total station, these methods require skilled labor and takes time. So the whole it decreases your productivity. This leads us to develop the software Pier to automate the analysis and the analysis of elevation and placement of Pier foundation. To use the software, we need a laser scan of a job site as an input. So to do this laser scan, it takes a minute to an hour, depending on the type of scanner and how the user set up the parameter of the scanner. After that, once we give to Pier this laser scan, it takes a second to segment the point cloud, analyze the data, and generate the report. On average, 30 seconds. So to give instruction for alignment correction and elevation correction. As a result, it enables real-time correction on real-time feedback on a difference in top elevation of piers and misalignment of piers locations. And so contractor can perform their own assessment, which increase productivity. Again, help to notice errors and is overall cost effective. Next in the presentation, I'm going to present how the software works. So first I'm going to start with the segmentation step. So we're starting with a raw 3D point cloud. So this is the point cloud we have just after performing the laser scanning. The first step consists in identifying the ground and so remove it. To do so, we use a Rensag algorithm, which is a famous algorithm to identify the dominant plane in a 3D point cloud. And in addition to Rensag to identify the ground, we have a trimming process where we just remove everything above the scanner because we know obviously it's not going to be the piers. So with this, we end up with this point cloud and our piers that are just here. After that, we're going to reduce the density of the point cloud to make the software run faster. To do so, we have a downsampling step, which just consists in diminishing the density of the point cloud while keeping the overall geometry and the overall structure. Also, we remove border point using a KD3 data structure. So KD3 is a space partitioning data structure that allows to efficiently go through a point cloud, and so we use this to efficiently go through the point cloud, identifying the point at the border and remove them. After that, after this pre-processing step, we're gonna use dbScan, which is a famous clustering algorithm to cluster a point based on density. So we can see after running dbScan with our pre-processed point cloud, we can see our pairs have been correctly identified. But then we only want to retrieve these 6 pairs. So to do so, we have implemented a filtering step where we go through each of the cluster, using what is called the minimal bounding box rectangle algorithm, which consists just in computing the minimal rectangle that contain all the points of each cluster. So we can see this minimum bounding box rectangle in green, and we compute the actual contour of the cluster with alpha shape algorithm that we can see in red. And so if the difference between the minimum bounding box rectangle and the actual contour is small, it means we have a pier. So we retrieve the cluster, and at the end we end up with R6 cluster, which are R6 piers. So after successfully retrieving the piers foundation from the point cloud, we can start the analysis process. So first I'm going to talk about the analysis of elevation. What we do, we compute the highest point of each pier, select the overall highest point, overall global maxima, and then compute the elevation difference between this highest point, so the global maxima, and each pier, so which give instruction about elevation correction. Next is the analysis of placement step. So basically, first, based on the centroid of each of the piers, we compute the diagonal, which assess the quality of the placement. Also, we compute the correct placement with the minimum bounding box rectangle algorithm I mentioned. So we compute the minimum rectangle that contains all the piers, and we compute the actual placement in red. With this, we can show the user detailed instruction about adjustment that needs to be done in order of the piers to match the location of the correct placement. As a result, piers was demonstrated on the mockup scan. So we placed manually 6 masonry piers, and so the dimension of the site is approximately 3.7 meter by 7.1 meter. With this scan, we identified this current limitation. So as you may have noticed, we assume a rectangular shape piers, and so we're currently working on making the software being able to identify a more complex shape. Also, we do not give instruction on levenness of the top surface of the piers, and this is a feature we want to add. Also, guidance can be misleading if installation error is very large, since we're using a minimum bounding box rectangle algorithm. And also we have seen some failure with low scan density point cloud. To conclude, so piers, the software piers show that automated segmentation algorithm can be used to isolate points belonging to pier foundation from a laser scan, and we can use this to assess the quality of the placement and elevation of pier foundation on site. Ongoing effort consists on improving the robustness of the algorithm and conduct more real construction site demonstration to assess the robustness. Thank you for your attention. Now we will be glad to answer any questions you may have.